All right, so here we have our Energy Systems Laboratory. This is my favorite lab in the college, besides the manufacturing lab, of course. It's very nice. We have a lot of cool stuff in here. But back here, this is the crown jewel of the Valparaiso University College of Engineering. It's our old girl, the heat pump.
Looks rustic.
I mean, she's not the prettiest, but she's been running here for a while, and she does a good job. You know, you can see here, we have this fine lead-based paint. We have a fin here. This is like our heat exchanger. It's made out of the best asbestos we could find. We have some very environmentally friendly R22 refrigerant, some good stuff there. And then there's some components in there, you can't really see them. It's a bit of a flaw, but they're all made in East Germany, so.
Is that good?
Yeah, it depends who you ask.
And what's that?
Oh yeah, this is just measuring the ambient temperature of the room right now.
Oh, nice.
Yeah. So yeah, what do you think about Valpo so far?
It's okay.
Yeah, you think you would want to attend school here?
I might want to take a look at Purdue.
That's what everybody says. So like I was telling you earlier, in our manufacturing lab, we're getting a new $50,000 lathe. That'll be in by the time you're here, so it'll be pretty exciting. And now we are in our energy system suite. And here's my favorite part, is our new and improved heat pump. This was actually built by some of our students. You can see here we have a very improved aesthetic compared to our last one, which is real old, wasn't really great looking. So we have this great tank here. We painted this ourselves. You can see all the components, they're visible. It's a really great learning experience. And then here we have our LabVIEW VI. This is basically where you measure all the temperatures, the pressures and everything. And I don't know how familiar you are with LabVIEW, but our very own Dr. Sestito invented LabVIEW. So if you have any questions about it while you're here, you can ask him and he'll be able to answer anything. Cool. So yeah, what are you thinking about Valpo so far?
I think this is the one.
That's great to hear. We would be very fortunate to have you.
The purpose of a heat pump is to transfer energy from one medium to another, typically to heat or cool space. The new heat pump in the Energy Systems Laboratory at Valparaiso University is transferring heat from ambient air to water in a tank with the goal of improving overall functionality compared to the old design. This heat pump system contains R134A refrigerant and transfers heat through the refrigeration loop. The refrigerant will be driven by the compressor and pass through the condenser, throttling device, and evaporator in a cyclical manner. This loop drives the heat transfer from the ambient air via the evaporator to the water in the tank via the immersed condensing coil. The tank stand, copper piping, and swage lock fittings were designed to provide longevity and enhance the performance of the operation of the system. While various instrumentation is connected at each major state within the site. The electrical subsystem utilizes LabVIEW software designed to read temperature, pressure, and current through the use of thermocouples, thermistors, amp meters, and pressure transducers. The students can see the temperature and pressure of the refrigerant changing at each of the 4 states, the water and air temperatures, and the power of both the compressor and the fan. The LabVIEW also includes a safety warning when the tank water reaches 120 Fahrenheit. In the future, the LabVIEW can also be used to do additional calculations and more advanced data display. After performing tests on the heat pump system, we found the net coefficient of performance to range from around 3 to 5 over the entire runtime. This net COP value means that we output 3 to 5 times as much heat in the water than the power consumed by the compressor. For our system, the compressor ran just under 300 watts throughout the operation, while the evaporator and condenser were transferring heat anywhere from 800 to 1400 watts.